Hi, I'm going to try something new because there was a lot to write. All right, this is 5.1, Math 135. Recall, demand is a function of the price. X equals D of P. Function of the price, P is price, and X is the number of items. So if we draw a graph where we have the price as the price increases, here's the quantity, and we can see as the price increases, the quantity decreases. And that's what I wrote here. As the price increases, the demand decreases. Okay? So now we're going to look at the demand as a function of the quantity. All right? Remember, X is the quantity. So the demand of the function of the quantity is going to equal the price. So again, now we flipped it. Notice here we had price and quantity. Now we have quantity and price. So our input is the quantity and our output is the price. And with this curve right here, we can see as the quantity increases, the price decreases. And that makes sense. If we have too much of something out in the market, then the prices are going to go down. Okay, so now let's look at the next one. We're going to be using integration here. The first one, utility, okay? So we're looking at the demand function where the items is X and the price is P. So if we go at X naught, all right, we're going to look at the utility, which is the area up to X naught. Utility is the total amount consumers are willing to spend for X naught goods. So how we would figure that out is we integrate from 0 to X naught. Okay, let's go to the next one. Right here, this is called consumer expenditure, the area of that little space in there. Notice we have X naught and P naught. Consumer expenditure, the amount consumers spend at price P naught. And so that's X naught times P naught, and that makes sense. X naught times P naught gives us that area. All right, if we were to take this and subtract this, we would get this, and that is called consumer's surplus. The amount consumers are willing to spend but do not. So just like we said, this minus this equals this, that's how we would calculate it. We'd integrate from 0 to X naught dx minus X naught times P naught. Okay, so let's do some examples. For the demand function, P equals D of X, which equals X minus 5 squared, okay, where the demand level all right, is X equals 3. Determine. Okay, letter A, the utility. Okay, determine the utility. That's this right here. So we're going to use this integration. So in our problem, we're going to integrate from 0 to 3 of X minus 5 squared dx. And of course, we're going to factor that. That gives us X squared minus 10X plus 25 dx from 0 to 3. Okay, and now we're going to integrate. So integrating, we add 1 to 2, X3 over 3. Here we're going to add 1, and we add 1 to 1, which gives us 2. We're going to divide by 2, so our end result is going to be negative 5. And then plus 25x. And we're going to be going from 0 to 3. Okay, so we put 3 in first, and we get 27 over 3 minus 5 times 9 plus 75, which equals 39. Okay, so we're going to continue on this problem because we're going to do more. Now the question is going to say, find the consumer's expenditure. Okay, so B, consumer's expenditure. Okay, we know X is 3. So D of 3, if we put it into our function, we have 3 minus 5 squared, which is negative 2 squared, which equals 4. So remember, consumer expenditure is X naught times P naught. So in our case, our X is 3, and our P naught is D of 3, which is 4. So that's 12. Okay, and last part of our question, consumer surplus. And remember, the consumer surplus is that we subtract the 2. So we're integrating from 0 to 3 of X minus 5 squared dx minus 12, which is 39, minus 12, which equals 27.